Hello everyone, thank you for joining the webinar on HP Multijet Fusion 300-500 series. My name is Surya Prakash and I'm working as an application engineer at HP, covering Southeast Asia, South Pac and India region. So let's look at the agenda for today. We'll be covering off a couple of interesting topic, HP Multijet portfolio, the fusing science, couple of case studies. The objective today is to deep dive into HP Multijet 300-500 series. Now, if you look at the HP 3D portfolio, we have products ranging from prototype up to volume production. So if you look at the prototyping area, we have the Jet Fusion 300-500 series, which is catered for low volumes. And then in the mid volume, where we have the 4200, which is able to produce industrial prototype as well as final part production. And then in the higher volume range, we have the Jet Fusion 5200 series as well. I've included here HP Metal Jet as a part of HP 3D portfolio, which will be launched in 2021. The HP Jet Fusion 300-500 series allows you to produce functional part in full color, black or white, with voxel control. What we have leveraged here is the speed, part property, and basically the 300-500 series is a cost-effective solution tailored for small, medium-sized product development teams, design firms, and universities. Now you can also produce very accurate functional part with intricate details, engineering great thermoplastic parts with optimal mechanical property, and achieve a fine detail and a wide range of application, which we will be covering off during our case study as well. Now, if you look at some of the examples here, these are parts produced using our 300-500 series, full color nylon part, where we have jigs and fixtures, biomodels, consumer goods, some of the part being labeled as well for tools for communication. These are the areas that you can think about, and it opens up a new applications. The Jet Fusion 300-500 series is designed for convenient in-house automated production. Basically, this is all-in-one solution where you send the file to the printer, it does the printing, it does automatic reclamation of the powder, and you take out the part and you can start bead blasting using a bead blaster and you get the final part ready. Now, what is built around this 300-500 series, as you can see, is a wide range of material which will be available in the near future. And then we have an integrated and automated system where the powder reclamation happens after the printing. And then we have a solution in terms of services where we have trainings for operators, for engineers that be able to use the machine efficiently. Let's take a look, a quick video on how 300-500 series works. We have the fresh material as well as recycled material, which is mixed automatically and supplied to the module. We have also the agents being supplied to the printhead module. Now the lamp module as well as the printhead modules work hand in hand, layer by layer, to produce the parts. As you can see, the build platform moves down while the part is being produced. Now let's take a deeper look into how the system works. So you can see the lamp module and also the printhead module is working side by side. Once the printing is done, cooling happens. After the cooling, basically all the unfused powder will go back into the powder recycle canister, and we have a full build job which is 250 mil height for 18 hours of printing, and for partial jobs we have 5 hours of printing, and all of these happens automatically once you press on print. When we take a look at a bit of technical information in terms of what are the size, what are the resolution that we are talking about of our printhead, and then in terms of printer dimensions, where you can fit it in, these are the essential information that you would need to require when you want to set up a 300-500 series into your facility. Multi-jet fusion technology and the fusing science. So now with a couple of slides, on the next slides we will be talking about how does multi-jet fusion works. So in this particular slide, it's basically explaining where the multi-jet fusion belongs to, which is the powder bed fusion. People get confused with material jetting as well as binder jetting. Multi-jet fusion is neither of these. It's the closest that you can compare is selective laser sintering, but even that is not 100% identical. Let's talk about step-by-step process on how multi-jet fusion technology works. Imagine the first step is spreading a 80 micron layer nylon powder onto the bed. The next step is we have the fusing agent as well as detailing agent is deployed onto the 80 micron layer. Now this fusing agent and detailing agent acts as in absorbing thermal as well as releasing thermal when heat is applied to the bed. And the third step is applying energy. So when you apply energy to the bed, the areas where the fusing agent is deployed will get solidified, or the temperature at the fusing agent deployed on the powder is elevated where the nylon starts melts. Now when this happens, the part is formed and this process repeats layer by layer. That is a basic concept on how step by 4 steps to conclude on how multi-jet fusion technology works. It is also important to touch base on our thermal printheads when we talk about page wide printing in our 2D business. This is where we are also leveraging our HP proprietary thermal printhead technology into 3D printing as well. Now, when we talk about the composition and the width, we are looking at a very high accurate nozzles as well as deployment of the fusing and detailing agent, which allows us to produce high intricate details as well as voxel level controls. Now we are talking about an agent is delivered onto the print bed each time it passes through the printhead carriage via thousands of nozzles, and these nozzles are smaller than a width of an hair. Let's jump on to case studies. Now what I have here is as a first case study is the medical area, which is the Reddy's Children's Hospital. Now Reddy's Children's Hospital is based out in California. It is used in pediatric medical research area. As you can see, the doctor is holding a biomodel with different colors representing different area of a model, like of a biomodel. Now, one of the important area here is that if you can think about different surgeons or doctors when talking to each other, this different color coordination actually helps them to identify certain area, as well as when they communicate to the patient, it brings up the level of confidence for the patient before they going through a surgery. Over here, I have a quick video that I'm going to share on the next slide.
The 3D Innovations Lab is a way for us to use 3D technologies, from virtual reality, augmented reality, to 3D printing to help our patients here at this institution.
Yeah, the models have been terrific in a lot of different spaces. Number one, obviously, it's helpful for us to be able to see the anatomy before we perform a surgery. It gives us some, like having advanced GPS. We can kind of see where we're going to go, what to expect. So for planning and for experience and for going in an educated way, it's fantastic.
So we actually published a study recently, about 2 years ago, showing how 3D printing has helped improve our outcomes. And in that study we found that with the 3D prints we were able to decrease our surgical times. We were able to decrease the amount of fluoroscopy radiation that the patient was getting during the procedure. And we were able to get equal deformity correction with our preoperative planning and with these prints. So it's really kind of objectively helped our patient outcomes.
There are quite a few different benefits from the HP MJF technology. One, it has full color capabilities, so we can create really rich, detailed models. The powder type technology really enables us to create very fine, detailed features. And the nylon that's processed by the MJF enables us to have very strong models. It's been an incredible resource. So we brought it into the institution here, and it's been an incredible success. 3D printing and 3D innovations as a whole has a major role in a hospital. It helps our surgeons, helps our doctors, helps our students, helps the families themselves, helps the whole team. By creating a workflow that enabled 3D printing, we brought this incredible technology in-house. It's helping improve our patient outcomes, but also helping our economics and helping new opportunities for device design and fabrication.
Now we have seen the medical case study. It was a very interesting video, and let's move on to fixture, jig and assembly aids. So let's talk a bit more about jigs and fixture. Jigs and fixture are tools that are used to aid in manufacturing lines, typically in terms of holding certain product, or it is also used to measure certain equipments. And over here what you can see is a go no go kind of gauge that was created using our 300/500 series with different color coding. Now we have also introduced the QR code over here. Basically, if you scan the QR code, you are able to know what is this particular jig is used for, where it is used for, how it is used for. These are the things that color can enable us to do in terms of jigs and fixture. And then when you look at the base material of our jigs and fixture are PA12 nylon. which allows functionality in terms of being tough to tolerate manufacturing line abuses. And also in the bottom left you can see one of the jig which was printed, and one of the customer testimony down in North America, Yazaki, they've mentioned here how does the color enable certain possibilities for them, basically in terms of visual communication, and allow them to basically produce better products in the market. When we talk about full functional color thermoplastic models, it's a definite yes for prototypes as well as visual models. Over here you can see there's a typical bracket that was topology optimized, and what we have here is that a loading in terms of color that is mapped onto the model and printed using our 300-500 series. These are very interesting model that useful for imagine an engineering department. Basically when an engineer speak with another engineer, they can basically use this model to have this type of discussion on how they can redesign certain parts to increase certain areas of the design so that they can produce a better part on the final part. These are good discussion point, as well as if you can think about trade shows when you would like to explain to a customer of a certain model. These tools or these parts can be super handy when it comes to trade show. As you can see, some of our customer testimonial at the bottom, which really help them in trade shows as well, in terms of the color that gives them a edge over discussions when they have. The next application that we want to talk about is the architecture model and GIS mapping. Over here you can see that a mock-up model of a globe that was printed in full color, and on the bottom left you can also see there is a mono as well as a color mock-up architecture model that was printed by our customer. Now we are seeing these advantages using our Jet Fusion 300-500 series is that we are able to produce parts which are really thin features for architectural models, which is strong and really useful, and enable to also produce accurate details on the model, which is again leveraging in terms of our Printhead technology, voxel by voxel control. And then when we think about the cost of the printing, now you are able to hollow the model, which you are able to extract the powder out and reuse it on the next build. Now here we are talking about being more affordable than material jetting. At the bottom there are also a customer testimonial explaining about how they've capitalized or benefited based on using our Jet Fusion 300-500 series for architecture models. The last and final case study I would like to cover off in this webinar is an educational case study. Over here we have Clemson University, who have adopted our 300-500 series into their engineering department and be able to produce parts that is super useful for their students and for their professors, and to basically to have this capability and be able to transfer the knowledge for the future leaders, which are the students. And on the next slide I have a video, like a success story video, and I will share that now.
Epson University is a public institution in South Carolina. As engineers, we have a lot of great ideas, and in order for us to be able to kind of realize those, we need an ability to see what we're dreaming. 3D printing is used within our senior design course to allow the student to see their product for the first time.
The Multi-Jet Fusion 3D printer is really incredible. Being able to print on the micron scale is mind-blowing. It's extremely helpful to have a printer that has that really low tolerance that can pick up all of the specific details we really need.
If I could only have one printer, it would be the HP Jet Fusion machine, just because it's easier to use and it's faster and it has super high quality parts. These stronger parts are actually allowing the students to do physical testing on their apparatus.
When our students see a prototype for the first time, their reaction is usually one of amazement.
It's fun to watch them when they first come in and I give them their part and they go, wow.
The first one that we printed, it was pretty incredible actually, because we put it in and the next day we were able to pick it up.
We can just take all the projects we get at the end of the day and put them in the printer, and I come in the morning and by 9 o'clock I have all the parts ready for the students to pick up. We started using color for everything now. I can print the black part, the red part, and rainbow colors and everything all in the machine at one time.
They've been able to realize their dream, what they're thinking in their head, what they see on their computer. So it's really a moment for them of true learning inflection.
It has effectively increased the capacity for the researcher in our lab by an exponential margin.
When they realize that they can do anything they want to, anything that they can design, basically we can print. I think that's going to change what they want me to print.
We're exposing them to how 3D printing processes work. They're able to use that in their education, but we're also teaching them how things are going to be made in the future.
Now that we have seen most of the application area that was covered during the webinar, I would like to also touch base on more application that could be enabled using our 300-500 series. Over here you can see application areas in terms of end of robot arm tooling, as well as consumer goods and post-processing application applied onto the 300-500 series parts. These are the possibilities that you can think, and these are endless possibilities. With that, I would like to jump on the next slide, which is covering off a bit of an educational promo here. Now what we have here is basically a 8-module educational curriculum. It it will be available in 2 waves. So we have 4 modules that is already available in the next month, and then the rest of the modules will be available down in November. What we have here is basically an objective of teaching the future decision makers about HP multijet fusion, and we also have a goal to provide some flavors of the modules to support training and teaching for executives to influencers today. And finally, the educational institute to start adopting HP multijet fusion 300-500 series into their ecosystem. Those are the main goals of this particular educational curriculum. And on the final slide, these are typical frequently asked questions. If you have any questions, please do reach us out. Please do email me on churya.prakash@hp.com. Now open for question and answer.